Welcome back to Databytez, your source for data-driven principles. Today we are continuing our discussion on data structures, moving on from arrays into hash maps, hash tables, dictionaries, all the same thing. Now, I like to call them dictionaries because it's very indicative of what they actually do and how they work. So like a normal dictionary, you have a word followed by a definition. You can look up any word and find the appropriate definition right next to it. So like that, we have, instead of a word, we have a key. And these letters here represent our different keys. And then the definition or the value that key is tied to. For the people who are more interested in the technical aspects here, the beauty about dictionaries is that they're very fast. So no matter how big the dictionary gets, as long as you call it by its key, it will return the value in what's referred to as an O of 1 algorithm notation. Big O, I believe. That's the term for it. And so it's constant. It's constant speed. Doesn't matter how big it gets, how many elements are in your dictionary, it'll always return fast. And it does this by a hash function. Again, details, kind of irrelevant for really getting the gist of what's going on here. And so when you iterate through a dictionary, kind of like we iterated through an array in the previous video, you do not actually get the elements first. What you do is get, and let's make sure this is constructed here. When you iterate, you get through the keys. And in order to get the actual elements, you have to call them by the key. So as you iterate through, instead of returning I, printing I, which is the element that is getting iterated through, we now put I next to the dictionary. And again, this is how you call, I think the exact term is, I can't remember the exact term right now, but this is how you call a dictionary by key. And then now we get the elements back. Again, not to get tied down too much in the specifics of any language, our goal is to kind of see how pervasive these concepts are, how pervasive these data structures are within different technologies. And so the beauty about dictionaries, and kind of discussing this in the original video on the importance of data structures, what they are and why they are important, is that dictionaries are referred to as semi-structured data structures. And that's because while there is a certain format on dictionaries, meaning you have the key value pair, you aren't necessarily limited on what you can make the value. So, for instance, in the first dictionary we had 1, 2, 3, 4, 5, but you can actually put lists instead of just a single value. So you can put A followed by a list of 1, 2, 3, 4, 5, B, 6, 7, 8, 9, 10, and so on and so forth. And then you have a more complex dictionary. Now, this can keep going. Like, you can have dictionaries within dictionaries. And so, as you can imagine, it can get very hard to look at. And that is why JSONs generally have a certain format requirement to kind of make things easier to read. And you can look online for like JSON formatter, and you can kind of paste these things in there to kind of get that kind of look that makes it just easier to read. We're not going too deep into it, so we don't really need to bother with that. But now, in our dictionary 2, if we were to iterate, we still get the keys, but now if we were to iterate a second time, we're getting all those lists back. And so the beauty of this flexibility is that we can put more information into one structure. And again, going back into our discussion on why data structures are important, knowing them is that some are more efficient in handling other problems. So if you had a more complex data set that you needed to work with, and you needed to store different tables, different arrays inside your dictionary, you can, or you need it to be able to access different tables, and you want it, and that depended on some kind of key value. Using arrays on their own to achieve this would be very difficult in comparison to just using a dictionary, because you can store the different arrays within the dictionary and just call them by that key value and just get them returned. Trying to do this in other ways, you can certainly brute force your way, slam your head against the wall and be like, I'm going to solve it this way, but this is a lot more convenient. And because it's very fast, it scales very well, unlike a series of lists would do. It would not scale at the same efficiency. So again, knowing these data structures allows you to be more efficient in your implementation, allows you to solve problems a lot easier, trivializing a problem that might seem difficult at first, but actually just needed the right data structure to kind of work with whatever algorithm you're setting. And a quick word on algorithms. Sometimes we hear that word and you must think it's algorithm is just a series of steps. And so it's just putting in a data structure into whatever series of steps you need it to work with. So we covered dictionaries in Python. Now we can look here in Excel. So we have a key here, A, B, C, D, E, and again our sequences here. And we create these sequences with a function, the sequence function, not really relevant, but we want to be able to call a key and return the sequence. So I have a little drop down here, and you can see there are different ways to do it. So we're getting the same kind of response, right? We're calling a key, and we are getting the array back, the list back. And we can do this via formula. Now there's multiple formulas that allow us to do this. We can also do this with the king of search functions, which definitely deserve its own video, but XLOOKUP. So we can say we want to look up here. This is our lookup array. This is our return array. Not found, we'll just put blank, and this should work. Yeah, see? So again, multiple ways to achieve the same result. And at the end of the day, the behavior is the exact same way. Now we can also iterate through, but unfortunately Excel doesn't have an exact one-to-one match in the same way that Python does. And again, just not everything is available to the same degree as they are across technologies. Programming languages, almost all of them have the same way, but Excel being a little different, it has a little bit of limitations we have to work with, but the ideas are still basically the same. So I have this hidden away here. So if you recall from our previous discussion on arrays, this blue line here indicates that they're all part of the same thing. So if I put a value here, it spills. And so the issue here is that while we're iterating here by row, referencing that original key all the way over there, it kind of just makes it all in one thing. We can't really make it work with the same by row and lambda function pair that we were working with before. And so you're going to have to deal with the fact that it all comes in one. And that's just the limitation of Excel. Excel isn't really built the same. Not programming languages are, general programming languages are built different. And that's the kind of the distinction I need to make here. Excel is, while it is a programming language, it is not a general programming language. It's not meant to do the same kind of things and work with your computer in the same way. So it has a bit of a different flavor, but we can still use the same kind of logic here of a key value pair to work with. Now this can become very useful if you need to call something and you need to work with the values it returns, and then work with those values afterwards. So for instance, let's just say you want to see employee A's record. There's more than one way to do it, but you could also say, I want to take the top 3 of employees A's results and return it. So you can just say, I want to take this and I want to feed this This should work. Oh, not that way. There we go. So there it is. I have the top 3 results spilling from there, and maybe I want to do something more, and then it grows in complexities and what I need to do. But it starts with being able to pull it out. And I have 2 different ways. There's even more ways to do stuff. Usually in Excel, there's more than one way to skin a cat. In programming languages in general, there's more than one way to skin a cat here. But that really covers our discussion on dictionaries. Again, the key part of a dictionary is the key value pair. That is the concept that works. Think about it, how it bleeds through and is a normal dictionary. And also the fact that it is fast. It is very fast, especially in general programming languages. Not as fast in Excel because we have to use functions that are not as efficient as the hash function that underlies the programming languages themselves, but still really great for our purposes. You really won't notice the difference in terms of speed, but it is different. So that ends our discussions on dictionaries. Have a great one. Tune in for the next one where we cover n-dimensional arrays.